Morning, this is Kasturi Day. Today again I'll discuss this electricity chapter according to ICSE syllabus class 8. So today I'm going to start with electric fuse. Okay, so electric fuse is a device which is used to limit the current in an electric circuit. Okay, when there is an overloading, when there is excess supply of electricity in the circuit, a wire of the fuse that melts and that breaks the circuit and limits the electric circuit so that the short circuit or when the circuit due to large withdrawal of current or due to any short circuit or due to fluctuating voltage wires and breaks the electric circuit. Okay, it consists of a solid. What it does it look like, or what is it made up of? So this is made up of a solid porcelain grip, okay, having two rectangular copper clamps on the sides. These clamps fit tightly in the terminals T1 and T2. See, from this picture you can see this this one. See, this is the fuse, this is the clamp, this is the socket. Okay, this portion is a box, this is a socket. Okay, and this is there are the two clamps on which the fuse wire is attached to. Okay, this fits into this socket. Okay, and this fuse wire, this portion, this one is attached in an appliance. Okay, and this is the main fuse where the electric supply is going through. This is attached in the circuit of the main line inside the house or inside the any building. Okay, so due to fluctuations of the current, it consists of a solid porcelain grip which has two copper clamps on the sides, and these clamps fit tightly in the terminals T1 and T2. Porcelain grip fits into a porcelain socket. Okay, this is the first one which I showed you. That is this one is the grip, and this this one is the grip, and this is the socket into which the grip is fitting. Okay, and these two other copper grip, this one is the copper clamp. Okay, so this fuse wire is fixed between these two copper clamps, and fuse wire is fixed between the two copper clamps. Okay, and this fuse wire is an alloy of 60% tin and 40% of lead. That means two metals are used for this making this fuse wire. They are made into an alloy that is 60% of tin and 40% of lead, which is and this fuse wire is a short and thin piece of wire of low melting point. This fuse wire has low melting point so that it can melt very easily and break the circuit, avoiding any fire. Okay, different fuse wire can have different thickness. More the thickness of the wire, more the electric load it can withstand, and vice versa. That is, if the thickness is less, then it will carry less electric load. Okay, it can withstand. Then when the grip is inserted into the sockets, the terminal T1 and T2 get connected to each other through the fuse wire. Okay, now electric fuse, when there is an overloading or voltage fluctuations or breaking of the wiring, the fuse wire melts. Okay, and the circuit breaks and the current stops flowing in the circuit, and therefore it helps in disconnecting an overloaded or faulty circuit, and therefore it prevents electric fire. Okay, So I think you have understood. This one is the grip and this one is the socket. Okay, and these two are the copper clamps in which the fuse wire is attached to. Okay, and it fits like this. Okay, from this down picture you can see. Next is the characteristics of a fuse. The fuse wire is a short wire with a low melting point. The wire is made up of an alloy of lead and tin. Melts at about 200 degrees centigrade. Okay, wire connected. This wire, fuse wire, is connected in series with the live wire. Okay, its temperature rises much faster than the connecting copper wires when an excess current flows at its resistance is higher, and as its resistance is higher than that of the connecting copper wires. Okay, so its temperature rises much faster when the connecting copper wires other connecting copper from the other connecting copper wires, the temperature of the fuse wire that rises much faster, because when an excess current flows through it. Okay, because what is the reason behind it? Because its resistance, that is the fuse wire's resistance, is higher than that of the connecting copper wires. The other wires which are connected in series, they are also copper wires, but their resistance is less, and their temperature will also rise in much slower rate than the fuse wire. If you go fuse wire, it has a higher resistance and is temperature, so its temperature rises faster and so it can melt very easily. Okay, the thickness of the fuse wire depends on the current rating of it. Okay, higher the rating, the thicker will be the wire. For example, see 15 ampere if it is written, if it is showing 15 ampere fuse, that means that is much thicker than 5 ampere fuse wire. Then heating of the fuse wire does not depend on its length. How much it is length is that is not responsible for the heating of the fuse wire. It depends on the thickness. Thickness and its melting point. Okay, so note an ordinary copper wire must not be used as the fuse wire, as its melting point is much high. It's not like the usual fuse wire, because fuse wires melting point is much lesser than the ordinary copper wires. MCB, okay, MCB are used nowadays. They are used as they can switch off the circuit in a very short time in case of short circuiting. And the most advantage in this MCB is that it does not melt. It just breaks the circuit by switching it off, switching the switch off. Okay, in the off position, off mode, it goes to the off mode without being melted. Like the fuse wire melts, but MCB does not melts. It's just cut off the currents. Okay. Next, we come to MCB. What is MCB? MCB's full form is miniature circuit breaker. It is an automatic switch that is nowadays used to protect the household wiring from excessive flow of the electric current in the circuit. Okay, it is placed in series in a given electric circuit in live wire and switched on. See, this is the picture of the MCB where it is in the on position. Okay. Now, if there is an overloading, excessive flow of electric current, then it goes to the off mode, off position, and the circuit breaks. Automatically, it falls. That means MCB falls down into the off mode and the circuit breaks. No current will flow until the fault is rectified. Okay, it is reset when the fault is rectified. Okay. Next is household electrical circuits. See, in the household, electrical circuits are connected separately. Okay, for example, a bulb can be lit without running a fan. Okay, that means, or when one bulb fuses or any appliance becomes faulty, then it does not affect the other working of the other appliances in the house. All the appliances work at the same voltage, that is 220 volt. Okay. And why this happens? Because in our homes, offices and schools, factories, all these cases, the electrical circuits are arranged in parallel condition. Parallel connection is there and not in series connection. So, electric circuit in a room, electricity supplied to us is 220 volt, I told you, through a cable wiring which has 3 wires, that is live, neutral and earth wires. From the distribution board, electricity is distributed to various parts of the houses, that is room, that means the living room, then kitchen, then toilets, etc. So, all these wirings are there. Okay, all appliances are connected in parallel. So in the houses, in houses, then offices, then any auditoriums, these all, in all these cases, these appliances are connected in parallel condition. Okay, each appliance has a separate switch connected to its live wire. Okay, now earthing of the appliances. See, earthing, what do you mean by earthing? Earthing means that the metal body of an appliance is connected to the thick copper wire, that is, or which is buried deep inside the earth, and its other end is connected to the copper plate surrounded by a mixture of charcoal and common salt. Okay, so the metal body, from the metal body of the appliance, the copper wire is connected to the earth, buried deep inside the earth, and its other end is connected to the copper plate surrounded by a mixture of charcoal and common salt. The reason is that sometimes due to the breaking, why this is done, because during any condition like breaking of the insulation of the wires, the live wires comes in contact with the neutral wires, okay, with the body of the appliances, or it gets a fatal shock which affects one's nervous system when the appliance is touched. Okay, so the live wires, when it comes with contact with the body of the appliance or any other person, it may come in contact to, so, and the current will flow through that portion. Okay, so that can create a very dangerous condition. It may create a fatal shock which can affect one's nervous system when the appliance is touched, and therefore to protect the person from an electric shock, the appliance is earthed and the current passes to the earth. When an earthed appliance gets short circuited, then the current from its metal body flows into the earth, as the earth does not offer any resistance. Okay, so the magnitude of the current in the circuit of the short-circuited appliances suddenly rises to a very high value. It will not provide any resistance. Okay, this rise overloads the circuit's melting point, melting the fuse. Due to this melting, the short-circuited appliance will not receive any current, and therefore the appliance is protected from being burnt out, or the person who is touching it will be protected from any electric shock. Okay. So I'll stop here. I'll continue with the rest of the remaining chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. And hope you are liking the videos. And if you are not liking it, please do give suggestions. Write in the comment box. Okay. And if you are liking it, press the like button, share with your friends. And also do subscribe to get the notification of my next video, so that I also feel some enthusiasm to produce you some more good videos for you. Okay, and thank you for watching. And also I'll be launching a website soon. Work is going on that. Okay, and so thank you for watching. Thank you.